Most of the loads are inductive in nature. So here we are considering the load as RL load. If thyristor 1 is triggered at an angle alpha with a pulse in positive half cycle, it carries the load current as this. Due to the inductance in the circuit, the current of thyristor T1 would not fall to zero at omega t equals to pi when the input voltage starts negative. The current through thyristor T1 is going to start when the firing pulse is given and is not going to fall to zero at omega t equals to pi plus alpha. The thyristor T1 will continue to conduct until its current T1 falls to zero at omega t equals to beta. Now, the conduction angle of thyristor T1 is in between alpha and beta. The conduction angle delta equals to beta minus alpha. The conduction angle delta is going to depend on alpha as well as the load angle theta. If Vs equals to root 2 times of Vs sine omega t is the instantaneous input voltage and the delay angle thyristor T1 is alpha. Thyristor current I1 can be found by L di1 by dt plus or I1 equals to root 2 Vs sine omega t. Now solution for this is I1 equals to root 2 Vs by Z sine omega t minus theta plus a constant A1 e to the power of minus R by L of t. This is equation number 1 where Z equals to square root of R square plus omega L square and the load angle theta is given by tan inverse of omega L by R. Now, the thyristor T1's conduction angle delta is going to depend upon the alpha as well as theta. The constant A1 can be determined from the initial conditions at omega t equals to alpha I1 equals to 0. If you substitute that in the above equation, then you are going to get A1 equals to minus root 2 Vs divided by Z sine alpha minus theta multiplied by e to the power of RL alpha by omega. Now substituting the value of A1 in this equation, you are going to get I1 equals to root 2 Vs by Z of sine omega t minus theta minus sine alpha minus theta of e to the power of R by L of alpha by omega minus t. That is equation number 2. Now, at omega t equals to beta, omega equals to beta by t, where I1 equals to 0. By substituting this in the above equation, sine beta minus theta equals to sine alpha minus theta e to the power of R by L of alpha minus beta by omega. This is equation number 3. Now, the angle beta, which is also known as extinction angle, can be determined from this equation. Once beta is known, the conduction angle delta can be found by using the formula that delta equals to beta minus alpha. This is equation number 4. Now, the RMS output voltage, that is V0, which is nothing but V RMS, is equals to 2 by 2 pi integral alpha to beta to Vs square sine square omega t d omega t under the square root. Now, if you solve this, 4 Vs square by 4 pi integral alpha to beta 1 minus cos 2 omega t d omega t under the square root. Vs 1 by pi of beta minus alpha plus sine 2 alpha by 2 minus sine 2 beta by 2 under the square root. This is our V RMS. RMS thyristor current I1 RMS is given by 1 by 2 pi integral alpha to beta I1 square d omega t under the square root. We know the value of I1 from equation number 2. Substituting that here, I1 RMS equals to Vs by Z of 1 by pi alpha to beta sine omega t minus theta minus sine alpha minus theta of e power R by L alpha by omega minus t d omega t. The whole thing under the square root. RMS output current can be found by determining combining the RMS currents of the thyristors 1 and 2. So I naught, which equals to I RMS, equals to I1 RMS square plus I2 RMS square under the square root, which is approximately root 2 times of I1 RMS. The average value of thyristor current I average is given by 1 by 2 pi integral alpha to beta I1 d omega t, that equals to root 2 Vs divided by, if you substitute the value of I1 from the equation number 2, 2 pi z integral alpha to beta sine omega t minus theta minus sine alpha minus theta of e to the power of r by L multiplied by alpha by omega minus t d omega t average. If this is the gate signal for thyristor 1, the gate signal for thyristor 2 will be at pi plus alpha. For 1 at 2 pi plus alpha. The gate signals of thyristors could be short pulses for controlling with the resistive load. Such short pulses are not suitable for inductive load. When thyristor T2 is fired at pi plus alpha, the thyristor T1 is still in conduction due to the load inductance. But by the time the current of the thyristor T1 falls to 0, the T1 is turned off at omega t equals to beta, where beta is alpha plus delta. The gate pulse of the thyristor T2 has already ceased, and consequently T2 will not be turned on. As a result, only thyristor T1 will operate, causing asymmetrical waveform of the output voltage and the currents. This difficulty can be resolved by using continuous gate signals with the duration of pi minus alpha. This is a continuous gate signal here. For this also the continuous gate signal, and here the continuous gate signal. As soon as the current of T1 falls to 0, the thyristor T1 will be turned on. A continuous gate pulse increases the switching losses of the thyristor and requires a large isolation transformer for the gating circuit. In practice, a train of pulses with short duration are normally used to overcome this problem, like the equation 2 indicates that the load voltage and current will be sinusoidal if the delay angle alpha is less than the load angle theta. If alpha is greater than theta, the load current would be discontinuous and non-sinusoidal. If alpha equals to theta, then from the equation number 3, sine beta minus theta equals to sine beta minus alpha, which equals to 0. And beta minus alpha equals to delta, that equals to pi, where beta is the extension angle, alpha is the delay angle, delta is the conduction angle. Since the conduction angle delta cannot exceed the pi, the load current must pass through 0. The delay angle alpha may not be less than theta, and control range of delay angle is theta less than or equals to alpha less than or equals to pi. If alpha is less than theta, the gate pulse of the thyristors are of long duration. The load current would not change with alpha, but both the thyristor would conduct for pi. The thyristor T1 would turn on at omega t equals to theta, and T2 would turn on at omega t equals to pi plus theta.